36 asks us to use Bayes' rule. Rather than using Bayes' rule, I like to show it. So we've got two shipments. So let's make our tree diagram. Shipment 1 and shipment 2. Shipment 1 has defective and non-defective products. Defective and non-defective. Now here, 2% of its contents are defective. I'll write that as a decimal, 0.02. Now if 2% are defective, then doesn't that mean 98% are non-defective? They have to add up to 100% or they have to add up to 1, right? Shipment 2 has the same setup, has defective products, and it has non-defective products. Shipment 2, 5% of its contents are defective, that's 0.05. And so non-defective would be 95%, no? Okay. It's equally likely an employee will go to either bin. So the probability we get shipment 1 is a half, 0.5. The probability we get shipment 2 is a half, 0.5. So the person goes into a bin, picks a component. What's the probability that a defective component came from shipment 2? This is a conditional probability problem in disguise, right? It's conditional in disguise. Here's what the conditional setup is. If the component is defective, right? The probability that a defective component, that's something we know is defective, what's the probability it came from shipment 2? So in conditional probability language, what's the probability it came from shipment 2, given that we know this component is defective? Given that we know it's defective. So I'm going to scroll down some. So probability that it came from shipment 2, given that we know it's defective. Now if we're using, in effect, this is Bayes' rule, right? A conditional probability problem. We need the probability that it came from shipment 2 and it's defective, divided by the probability that it's defective, the probability of the event that's already occurred. So Bayes' theorem gives us a way to categorize this nicely. But we can see this, right? The probability that it comes from shipment 2 and it's defective, that's this path right here. Shipment 2 and defective. That's this path right here. Shipment 2 and defective right here. That's the only way you can get shipment 2 and defective. And those probabilities are 0.5 times 0.05. That's shipment 2 and defective. Now, the probability that a product is defective, here's where this tree diagram is nice. There's two ways that a product can be defective. It can be defective here from shipment 2, or it can be defective here from shipment 1. And each of those is represented by its own path with its own probability. So there's two ways a component can be defective. It can be defective from shipment 1, this path, or it can be defective from shipment 2, this path. So here's defective from shipment 1, and I'm going to express that as a probability here. Defective from shipment 1 or defective from shipment 2. That's the only way a product can be defective. From shipment 1 here or from shipment 2 here. Now we just have to do this calculation. What's 0.5 times 0.05? 0.025, right? 0.5 times 0.02. It's 0.01, isn't it? Plus 0.025. This is 0.025 divided by 0.035. I think this is 0.714, is it? Let's divide it and see. Yes. If I'm rounding to, does it say 3 decimal places? It doesn't say. Let's use 3 decimal places. 0.714. That's the probability that a defective component came from shipment 2.